This is going to be an overview of problem 26 from the 2015 Mathcounts Nationals competition, and it's from the sprint round. And we're asked like how many distinct four-letter permutations are possible using 4 of 10 letters in the word Mathcounts. And at first, we might think it's just like 10 choose 4, 10 choose 4 times 4 factorial. But the thing is that we see that the letter T is repeated. So although we have 10 letters, we have to consider different cases because we're going to overcount. And so we have to do some casework with the number of T's in each 4-letter permutation. So the first case we can have is when we have 0 T's. And the number of ways we can do this is, they're like, after we remove all the T's, we only have 8 distinct letters. And if we want to make 4-letter permutations, then we have to choose 4 from those 8 to like have like that set of letters to create the word. And then we have 4 factorial ways to arrange this. And this would give us 8 times 7 times 6 times 5. And this equals like 1,680 ways. And if you're not comfortable with like this notation 8 choose 4 and how to evaluate that, then I would suggest like looking up some stuff about it. But yeah. Okay, the next case we have to consider is when the letter permutations have 1 T in it. And since there are still 8 like letters we can choose from, to choose like the other distinct letters other than this T, there's going to still be 8 choose 3 ways to pick the letters. And then there's also going to be 4 factorial ways to arrange these, including this T. So this evaluates to 8 times 7 times 6 times 4, because like the 3 factorial on the bottom cancels a lot with 4 factorial. And so we can evaluate this, and the value is just going to be, it's going to be like 1,344, I think. I might be wrong, but I'll check my calculation later. And then the last case we can have is 2 T's. And the reason why I say this is the last case is because we only have 2 repeated T's, so that's like the maximum number of T's that can go in a set of 4-letter permutations. And since we already have 2 T's, we only have to choose 2 from the 8, so there's 8 choose 2 ways times the 4 factorial. But we also have to divide all of this, like it doesn't matter, but like I'll just divide this part by the number of ways that the T's can be arranged, because like if we had like some like letters like this, then there would be 4 factorial over 2 factorial ways to arrange this, because there's 4 factorial ways to arrange all of these letters, but then there's also 2 factorial ways to arrange these, because the T's are indistinguishable, so you have to divide by 2 factorial, and we should get 8 times 7 over 2 times 2 times 4 times, and we should get this, and then this should simplify, this cancels out, this cancels like this, so we should get around like 42 times 8, which is like 336, I think. Yeah, that looks right. And so we have all our cases, and like I said, there's no more cases because we can't have more than 3 T's or 2 T's, because we only have 2 t's in the word. So if we add all of these cases up right here, then this plus this should be 1680. And then you add the first case, which is also 1680. And you should get an answer of 3360. So going back to the problem, yep. So there would be 3,360 permutations of the letters Mathcounts. If you liked the video, consider following my channel, and I'll see you in the next video.